Hello guys, Sir DV again to discuss to you more on the redistribution of moment concepts. I'd like to introduce first the typical the typical strain distribution or diagram you always consider when we do some calculations on the uh, net tensile strain and the total uh, uh, tensile strain uh, corresponding to the crushing strain of concrete in the ACI, which is equivalent to 0.003. So this is the ACI definition of your concrete uh, strain during crushing. So as you can see here, this is actually the elastic strain distribution wherein your epsilon c has not yet reached the ultimate value of 0.003, while your steel strain here may or may not reach the yield strain epsilon y. Okay, so this point at which your steel strain starts exhibiting the yield strain is actually the start of your inelastic uh, behavior, on which we take note that ductility now is measured uh, from the point where this curvature Phy is defined and certainly increase the value of Phu such that your Phu over minus Phy is simply the measure of your ductility, and this is also the parameter used to compute for the amount of redistribution of your moments. Okay, so the amount of your distribution is actually uh, related to your ductility here. So later on, we need to get this total uh, steel strain epsilon t for us to define this percentage of redistribution. Uh, so in summary, the above figure shows that the strain behavior of reinforced concrete beams when the net percentage of reinforcement rather, which is defined on the basis of the tensile and the compressive reinforcement ratio, uh, is limited to a very low value. So when this is low, then your redistribution percentage may be quite big, okay? Because the reserve rotation is defined by the difference between your Phu and Phy is also big. And the availability for such redistribution will depend on these two. Of course, later on I will show you the difference between the two codes defined on the basis of rock and on the basis of your epsilon. So let's go now directly to what the code tells us. So I have here two codes. So this is an old code, and this is also an old code. So the change from this 1999 code to the 2002 code serves as the transition into what you call the unified provision on tension and compression control members. So in these two codes, there is defined on my previous lecture about a compression control behavior and a tension control behavior. So it simply means that for a compression control behavior, we are talking here more on a column behavior, while on the tension control, we are actually considering a beam behavior. Okay? So I will be discussing this perhaps on a different video. So let's take first on what the code tells us about redistribution of moments. So for your ACI 2002, section 8.4.1, it's stated that except for the approximate values for moments are used, it shall be permitted to increase or decrease negative moments calculated by elastic theory. It supports continuous flexural members for any assumed loading arrangement by not more than 1000 epsilon t percent with a maximum of 20%. So the modified negative moments shall be used for calculating moments and sections within the span, and the redistribution of negative moments shall be made only when epsilon t is equal to or greater than 0.0075. Okay, so these are the criteria for us to be able to use the moment redistribution procedure defined by ACI. So in ACI 1999, a few years back, so we define the amount of redistribution in terms of steel reinforcement ratio. So this steel reinforcement ratio, which was defined here as the main parameter, rho minus rho prime, okay, controlling it to be a low value to allow us redistribute the moment. And the amount of redistribution, which is the counterpart of 1000 epsilon t here, is equivalent to this value in percent. Okay, so the lower this value, the higher the redistribution percentage. So which means that we are just trying to make a more ductile design. So when the design is has a higher ductility in terms of the amount of reinforcement ratio, or in terms of the difference between the yield curvature and the ultimate curvature, then we can allow the distribution to uh, reach a maximum of 20%. In this case, if this is 0, then we can allow this to be 20%. Of course, there's no way, uh, but rather there's a possibility that your raw here is equivalent to your raw balance, okay, when you have a balanced design, and your raw prime is assumed to be 0. So when this is 0 and this is equivalent to raw balance, this becomes 1, and 1 minus 1, okay, 1 minus 1 becomes 0. So the redistribution of moment then becomes, uh, in terms of percentages, becomes 0. Okay? So is there a possibility for this to become 20%? Yes, if your rho and rho prime are the same, this value here, whole value becomes 0, and then this is 1 times 20, so this becomes 20%, which is still uh, the same as the limiting percentage given in our ACI 2000. So the modified negative moment should be used for calculating moments at sections within the span, and the redistribution of negative moments should be made only when rho minus rho prime is not greater than 0.5 rho balance at the section at which moment is reduced. Okay, so there is a restriction of having your rho minus rho prime to be limited only to 0.50 rho balance. So this is actually a basis of our uh, seismic provision for the activity. Okay, so in our ordinary or regular provisions, this is 0.75, but in the seismic provision, we reduces that much more down to 0.50 or 50%. And take note that raw balance is simply defined in terms of this formula, which is in English units. And for SI units, you just simply convert this to 600 plus Fy. Okay, so we have here a graph of this comparison between codes in terms of your calculated uh, uh, redistribution percentage. Okay, for ACI 2002 and 99. Okay, so the calculated available using the formula above, the 1000 epsilon t that we refer to above is simply this two here. Okay, so this is the calculated available uh, for Fy equals 60 ksi and for Fy is equal to 80 ksi. But for all Fy's and FPU, we can use this graph. Okay, but in 31899, there is a limitation, okay, upon which this graph can only be used within the boundary given by the dotted line. Specifically for Fy is equal to 60 and Fy equals to 80. So for the older version, ACI 6371, we have and those codes older than 99. So we have the calculated available, which has the basis of this 21 minus rho prime over rho balance. Okay, so this is are now calculated in terms of Fy equals 40, 60, and 80. So take note that when you have a lower uh, yield strength in terms of the steel, you have a higher, okay, curve that will give you uh, a better percentages in terms of the redistribution. This percent change in moment is actually redistribution percentage that we compute using this formula. Okay, for much older version ACI 31863, so we have this graph limiting our moment redistribution percentage only to 10%, and this is limiting our rho minus rho prime over rho balance at 0.50. Okay, so again, this is a seismic provision. And then in ACI 318-71, so they actually made some uh, adjustment. So the distribution may now exceed the value of 10%, and it can reach actually up to 20% when your rho minus rho prime is equal to 0. This can only be 0 again if your rho and rho prime are equal. Okay, so you can actually have the maximum value of redistribution percentage of 20%. So that is uh, the code uh, provides us with these rules, no, to follow. And in our next video, I will show you a general procedure on how to do the moment redistribution calculation uh, using this formula. Thank you very much for listening, and I'll see you in the next video.